Hi guys, my name is Terry. In this video, I'm going to go through the additional mathematics state trial paper for year 2022, and this is SBP paper 2. Okay, let's get started with question number 1. So here we have a distance between Ahmad's house and his sister's house. Aimi is 100 kilometers. So on a certain day, Ahmad drives to his sister's house with an average speed of X kilometer an hour and return home with the average speed of Y kilometer an hour. So the total time for the two journey is 2.5 hours, and you're given X is 20 kilometers more per hour more than Y. So you're supposed to find the time taken for Ahmad to go to his sister's house. Okay, so first of all, I think we have to form two equations. Now understand this, we have to use speed equals to distance over time here. We know this from his house to his sister's house, okay? Maybe you can say from Ahmad to Aimi's house, or should I say to sister's house, to sister's house, home or house. We know the average speed is X, and speed equals to distance. The distance is 100 kilometers. The time, let's call it T1. T1 is time taken for him to travel from his house to his sister's house. So let's make T1 as a subject. T1 will be 100 divided by X. Now, the second journey is, of course, to go back home. To go back home, the distance, the speed is faster, is Y, and Y is the speed equals distance, also 100, but the time, let's call it T2. Now, why do I call it T1, T2? Because we know the total time taken is 2.5 hours, so we can use T1 plus T2 equals 2.5. But first, we have to make T1 and T2 as a subject. In this case, T1 is 100 over X, T2 is 100 over Y. So we know T1 plus T2 equals to 2.5. So 100 over X plus 100 over Y should be 2.5. Now I need to simplify this equation. Maybe we can take out 100. This will be 1 over X plus 1 over Y equals 2.5. 2.5 you can think 5 over 2. So let's cross multiply. This is 100. If we cross multiply with Y plus X over XY, but we can actually write this as X plus Y over XY. And your outcome is still 5 over 2. Maybe I can take 100 divided by 5. 100 divided by 5 is 20. 20 times 2, this is 40. Yeah? So it's 40 X plus Y equals to XY. Maybe I just multiply inside 40X, 40Y equals to XY. Now we're going to leave this out and call this equation number 1. So I need a second equation. The second equation will be the difference between the speed. It is given that X is 20 kilometers per hour more than Y. So we know X is Y plus 20. And we can call this equation number 2. So let us sub equation 2 inside equation 1. So the moment we sub inside, we write 40Y plus 20 plus 40Y. And your X again is Y plus 20 times Y. Let us expand this. 40Y plus 800 plus another 40Y. When you expand the second bracket, you get Y squared plus 20Y. Now let's rearrange everything. You can see here, 40 plus 40 is 80. I move over to the right. 20 minus 80 is negative 60. 800 I bring to the right, I get negative 800. So what we have here is a quadratic equation, but we know we cannot factorize this because the question says, find the time given and give your answer correct to 3 significant. So whenever they say 3 significant, we know we can't actually factorize. So here we have two options. You either use quadratic formula, which is minus b plus minus square root b squared minus 4ac over 2a, or use completing the square. Now, personally, I like to use completing the square because especially when the number in front is 1, it's shorter actually. So I'll show you completing the square right here. Let's take half of negative 60. Negative 60, if I halve it, is 30. Okay, right? And 30, if I square it, is 900. Now you may be thinking, why do I do that? Okay, in school, your teacher most probably will tell you to use half of negative 60, which is minus 30. You square it, and then you minus it off. Now, the very reason why we want to do that is because this can be factorized into y minus 30 squared. And minus 30, if I square it, is now minus 900, right? So we have to subtract this 900 to cancel this term out, because originally it's supposed to be y squared minus 60y only, right? So I'm going to write this straight away. I feel it's a lot easier, for student to just skip this step here and go straight to this, Then you minus 800. As I bring this to the right, y minus 30 squared, this will be 1,700, as we can square root it. Now here we don't have to put plus minus because we know it's going to be positive. So let's do 1,700. Now you can actually put 10 17. I can, when you square root 1,700, right? Or 1,700 is just 10 17. You can write that if you want. And if I bring this over, y is 30 plus minus. Okay, sorry, forget about the minus, just the plus, because if you minus, it's going to be negative, right? So we put 1,700. Okay. All right. So I'm going to use my calculator, right? So 30. Okay. By the way, just to double check, you notice that this one, is negative. Just so you know, that's why I skipped the negative part. I just changed this to positive, right? So my y value is 71.23. 71.23. Now remember, y is the speed for the return journey. We want to find the speed that for the journey to the sister's house, which is x first. So you can sub inside equation 2. Maybe I write here. Sub inside equation 2. Your x should be 71.23 plus 20. That will be 91.23. Okay, once you know the speed to the sister's house, we can find the time taken. After all, you're finding the time taken to go to the sister's house. So that means I'm finding T1. I need to sub inside here, this one, this line here. So let's take T1 as 100. Divide 91.23. Use your calculator. 100 divide 91.23. Well, you will get 1.096. The question says give your answer correct to 3 significance. 3 significant will be 1.10 in hours. This is in hours. So I'll write this as 1.10 hours. All right. Okay, question number 2. So here we have an exponential logarithmic function, we call it fx equals to ln bracket 4x minus 2. You're supposed to find f3. Okay, so I'm going to do it over here. The first one is quite simple. F3 simply means putting 3 inside your x here. So this would be ln 12 minus 2, which is ln 10. This part here we have to use a calculator. Ln 10, if you type in your calculator, you should get 2.30. 303. For SF will be 2.303. Okay, second one, find a range of values of x when fx is more than 0, more than 5. So my fx here is ln of 4x minus 2, and it's more than 5. Okay, so I know some students were not familiar with ln. Ln basically is log base e. This is in your textbook, but it's just a small part. In the new KSSM textbook, right? So e is an exponential function, which is basically 2.71828. You can actually find here shift ln, you get e. E by itself is a constant, 2.71828, and so on. Okay, so here's the thing. We need to change from logarithm form to index form. So normally we say log base a y equals to x. Y will be a power x. But this is ln. Ln, let's say y equals to x. So we say y is e. Ln means log base e. E power x. So here we write 4x minus 2 more than e to the power 5. And we're supposed to find the value of x. So we can bring the 2 over, e power 5 plus 2. Then we divide by 4. Now, this question didn't mention specifically whether you should give your answer as exact form or in decimal. So you can leave it like this actually, is fine. Or if you change to decimal, just make sure you use 4 significant figures. So it looks like this, shift ln e power 5, right? Then you plus 2 divide by 4. And my answer is 37.60. Yeah, 37.60. There you go. That is for part A. All right, let's move on to part B. Okay, let me move this up a little bit so we got a bit more space. Okay, for part B, I think I would do it down here. This one we have to use substitution to solve it. It's easier to use substitution. You can see there's an m power 1 over 3 and m power negative 1 over 3. So we know we can let the one with a power 1 over 3 becomes u. Now, by doing so, this becomes u equals 2 plus 15. This is m power negative 1, 3. So it's actually u power negative 1. Now, to simplify this equation, we can just multiply everybody by u. So here we got u squared equals 2u plus 15. Bring everything to the left. U squared minus 2u minus 15 equals 0. Can we double bracket? What is the factor of 15? 3 and 5. Yeah, I want to get minus 2. So the bigger number 5 must be minus. Smaller number 3 must be plus. Now we know u is either negative 3 or positive 5. But here's the thing, if you sub back inside, you got to double check whether this answer is valid or not. Sometimes we have to reject the answer, sometimes we don't. Okay. Now, in this case, yes, we can accept both answer because here is a power 1 over 3. If it's power 1 over 2, then you can't square root m and get negative, right? But cube root, yes, it's possible. So we write m as negative 3 power 3, which is negative 27, and m as 5 power 3, which is positive 125. Right. Okay, question number 3. This is from the chapter quadratic functions. So the first part is very interesting. You are supposed to prove or show that alpha plus beta is minus b over a and alpha times beta is c over a. You're given a quadratic equation, ax squared plus bx plus c here, and it has roots of alpha and beta. So in order to show this, right, I think it's best we start off from the roots. We know that your roots are alpha and beta. So we can bring this over and write x minus alpha. Bring the beta over x minus beta. The whole thing is now equals 0. Now let's expand this. You should get x squared minus beta x minus alpha x plus alpha times beta. Let me show you here. Yep, maybe I show the arrow here, easier to understand. We basically multiply 1, 2, 3, 4, expand. And we can put your alpha beta together. So normally we put alpha first, beta at the back. And here you notice I factorize negative as well as the x. So I put alpha first and then beta later. So if you write beta plus alpha, is actually the same as alpha plus beta. But normally we put alpha first, beta later. And then we add with alpha beta, the result is 0. So here you go. This is your quadratic equation. And what we want to do is you want to compare with this quadratic equation that you're given, ax squared plus bx plus c. But for this equation, right, we should divide by a. As I divide by a, you will get x squared, b divided by a. So this is b over a, positive b over a. And then c also divide by a. The result is 0. So by comparison, by comparing them, we will be able to find alpha betas. Yeah, let me compare the number, the coefficient of x. That means the number in front of x here. All right. So we say negative alpha plus beta is b over a. Bring it over alpha plus beta is negative b over a. Then let's compare the constant, the one without any x or x squared. I got alpha beta and the result is c over a. All right. Okay. It's not too difficult, the first part. But then they say, hence, find the sum of roots and products of roots for this equation. So we know that this is actually your sum of root, or we call it SOR. And the second one is your POR. So for this equation, starting from 2 over 3x squared equals to 5x plus 2, we'll just multiply by 3. As I multiply by 3, I get 15x plus 6. And I bring over to the left, double bring over to the left, you can see that your A is now 2, your B is negative 15, your C is negative 6, right? And with that, we can find our SOR, my sum of root, maybe I can write alpha plus beta. I'm using the result here, sum of root minus B over A, which is 15 over 2. My POR, or my product of root, which is your alpha beta, is C over A negative 3. Right. Okay. Now, let's move on to question part B here. I'm going to do it here. Now, part B is actually solving a quadratic equation involving quadratic formula. Okay. All right. So here we have a function fx, but it's actually nothing much related to function. We let this function fx equals to 4. Okay. You're given fx equals this, and you're supposed to find the possible values of x given that fx is 4. So let's write 1 over x plus 2 plus 1 over x minus 3. The result is 4. And when we cross multiply x minus 3 plus x plus 2, divide by these two, multiply together. I do a bit slower here. X plus 2, x minus 3, the result is 4. Okay, so as I simplify, this is 2x minus 1. Maybe I expand the bracket first. X squared minus x minus 6 equals to 4. Let us bring over to the right-hand side. 2x minus 1. This is 4x squared minus 4x minus 24. Bring the 2x and minus 1 to the right. I have 4x squared minus 6x minus 23 equals to 0. Okay, not really a nice number, but here we're supposed to factorize. We can't factorize. We're supposed to use quadratic formula and get this. Now, you can actually complete the square. It's just that it's a little bit harder to complete the square if the number in front is 4, right? If the number in front is 4, you're going to divide by 4. So maybe in this case, I would just use quadratic formula. Remember, for the previous question, I've shown you the formula minus b. B is negative 6 plus minus square root. Your b is negative 6, you square it. 4, a is 4, c is minus 23. Divide by 2a. My a is 4. So let's simplify this. This is 6 plus minus. This will be 36. Negative 6 squared is 36 minus 4 times minus 23. That will give us 404. Yeah, 404 divided by 8. Now notice that we can simplify further, right? Because 404, actually, if you use this type of calculator, they can actually simplify for you to this. Yeah, but we also know that 404, you can divide by 4, obviously. When you divide 4, you get 101. So let me write more step for you. 6 plus minus. So it's actually 4 times 101 divided by 8. We can take out the 4. Square root 4 is 2. Leave it as 101. Square root, leave it inside, divide by 8. So both of these two, 6 and 2, can divide by 2. As I divide by 2, I get 3 plus minus square root 101 over 4. Now we can always double check using a calculator actually. So this is not a secret anymore, but it's good that you know. To show you this mode, you go to number 5 equation, go to number 3, then we key in our x, y, z. Your x is 4, your y is negative 6, and my z is minus 3. My ABC. Yeah, you notice you will get your x value, x1 as 3 plus square root 101 over 4, and x2 is 3 minus square root 101 over 4. Yeah, 1 plus 1 minus. Okay, question number 4. So this is from differentiation, the chapter form 5, chapter 2. It is given the equation of the curve y equals x cubed minus 12x. A straight line touches the curve at point K. Find the equation of that straight line. Okay, so number 1, let us differentiate. We know that if a line touches the curve at one point, we say that the line is a tangent to a curve. But to find the gradient, we have to differentiate and substitute, right? Then only you can form equation of the straight line, equation of tangent. Okay. So number 1, let us differentiate this. This is y equals to x power 3. Sorry, you can't see. If you can't see the x power 3, you bring the power down, copy x, reduce the power by 1, differentiate negative 12x, you should get minus 12. Okay. Now at the point where k is 3 minus 9. Our x value is 3. So we sub 3 inside. My dy dx will be 3 times 3 square minus 12. So this is 27. 27 minus 12 is 15. Yeah, this 15 represent the gradient of tangent. So to form equation tangent, let's use the formula y minus y1. Okay, let me write down a formula for you in case you're not sure. From the coordinate geometry, y minus y1, m x minus x1. My y1 is negative 9. My gradient is 15. My x1 is 3. So this is 15x minus 45. The plus 9 you bring to the right becomes minus 9. My y is 15x minus 54. There you go. That's your equation of straight line. Okay. The next one, we're given x plus, for part B, we're given x plus 2y. It is now 4. And we're supposed to find the minimum value of p, given that p equals to x squared plus xy minus y squared. Okay, so first of all, if you want to find minimum maximum for p, we need to convert this to a function p in terms of a single variable. The variable can be x, can be y. But since you notice that the relationship between x and y is given here, and I think it's easier to make x as a subject. So x is 4 minus 2y. We can call this equation 1. Call this equation 2. By substituting equation 1 inside equation 2, your p is now, your x is 4 minus 2y. You need to square it plus 4 minus 2y again. You multiply y and you minus y squared. Right? So what we need to do is to expand and simplify this. So this will be, let us expand the bracket first. This is 16 minus 2 times 4 is 8. 8 times 2 is 16, 16y. And 2y, if I square it, is 4y squared. Multiply the y inside is 4y minus 2y squared minus another y squared. So let's simplify further. This 16, minus 16 plus 4 is minus 12y. And then you have 4 minus 2 minus 1. That means 4 minus 3. 4 minus 3 is 1. So what I have here is 16 minus 12y plus y squared. Okay, with that we can differentiate dp dy. Remember, minimum maximum happens when the gradient is 0. Now we know, actually this by itself is a quadratic function. So we know it's a curve like this. So today if I were to sketch the graph of p versus y, it should have a minimum point. And that minimum point happens when the gradient dp dy is 0. So first we differentiate. I differentiate 16, you get 0. Differentiate minus 12y, you get minus 12. And this will be 2y. Let dp dy be 0. Solve for y. Okay. So bring it over. Your 2y is 12. Y is just 6. But don't stop here. We're not finding for y. Yeah, we know y is 6 here. The minimum happens when y is 6. But to find the minimum value of p, we take your y value, sub back inside your p, this equation over here. Your p is 16 minus 12 times 6 plus 6 squared. Okay, let's use our calculator, right? So here, let me just type in 16 minus 12 times 6 plus 6 squared. 6 squared is 36. Your answer is negative 20, right? So your minimum value can be negative. That means this, if I have to draw the graph is below. But it's okay. It's okay to get the graph below. It's not a problem to have a minimum value that's negative. Okay, moving on to question number 5. This is from the chapter Circular Measure. So here we have a Mathematics Society of SMK Cemerlang. They organized a competition to design a logo for the society. So here you have a logo designed by Husseini, ABCD, ABD, CBD, a sector circle radius of 8 cm, center DAC. So you're supposed to find perimeter and the area. Okay, so first of all, to find the perimeter, before you even find the perimeter, you can see that if this is a radius of 8 cm, this is a radius of 8 cm. At the same time, this is also a radius 8 cm, right? I hope you can see this. This is also 8 cm. So it's actually a rhombus. And not only that, if you were to join this together, you can see BD is also 8 cm. So they are all 8 cm. So all these are of equal length. So what can we say about, let's say, angle ADB? So angle ADB should be what? Should be 60 degree. Yeah, maybe I should say here, I should mention that AB equals AD equals BD. Yeah, they're all three equal length. So angle ADB is 60 degree, or you can convert to radian, pi over 180. This is pi over 3 radian. Okay, so it's important that you know that if this is 60, in fact, this is also 60 over here. I hope you can see. Maybe I should use a color pen here so that you can see this is 60 here. This is also 60 here, right? And this is 60 here. In fact, all are 60. Yeah. In fact, it is 60 on the other side as well. So then let's focus on this arc. This arc will be based on the 60 degree, right? Yeah. Arc BD, it has a center of A, right? And then this arc and this arc, they are equal length. And this arc also equal length. And this arc also equal length. So that means you have 4 length of arc with a center of angle subtended center of 60 and radius of 8. Then you also have another 2 radius here. The green one is the radius. So by finding this sum, we will be able to find the perimeter. Okay, so let's find the length of one arc. Okay, we know radius is 8, theta is pi over 3. But remember, in circular measure, they will always ask you to use 3.142. So here, I will use 3.142 here, 8 times 3.142 over 3. So this is 8.379. Yeah, 8.379 cm. Okay, so this represents the length of one arc. So to find the perimeter for the shaded region, right, we have 4 of this arc plus 2 of the radius. The radius is 8. So let's count. Take this 4 times 8.379 plus 2 times 8 cm. My answer is 49.52. Okay, I think if you do it directly, right, you will get 49.51. But that's okay. Directly, as in, some people may say, can I use 4 times 8 times 3.142 over 3? Then you add 2 times 8. You notice that you actually get 49.51. That is also okay. Yeah, 49.51. Okay, if you do one shot, or even if you use more decimal point for this length of arc, I think you will get 49.51. Okay, next one. How about area of shaded region? Okay, you can see a shaded region actually is a segment. I hope you all know the formula for segment. Yeah, I like to use a formula for segment because it's a lot faster. So a segment, it actually consists of a sector of a circle subtract area of triangle, right? Now we know that area of sector is half r square theta. Now this triangle here, you learn in the chapter solution triangle, we say area of triangle is half AB sine C, where AB are the 2 sides here. In this case, is R and R, and C is an angle in between. We call it included angle. In this case, is theta. So we take half. Your A is R, your B is also R, so we call it R square. Sine, because R times R is R square, sine of the angle between theta. And here, I would like to factorize the R square and a half. You're left with theta minus sine theta. But remember, when you use this formula, this theta here must be in radian, because when we derive this formula, we derive the formula half r square theta based on the fact that theta is in radian. But the second theta can be degree, can be radian. Okay, it doesn't matter. It depends on your calculator's mode. Okay, so let's say I would just do half r square. My r is 8 square. My first theta I use radian. In this case is pi over 3 minus sine 60. Now, if I were to use this, my calculator must be in degree mode. It's very important because sometimes some students tend to mess up the mode in the calculator and end up getting a different answer. See, if you don't do anything, your calculator by default is in degree mode. Yeah, there's a D here. You can change the mode by pressing shift mode. You choose number 4 for radian, number 3 for degree, right? So let's say stick with 3. I'm going to type in half. The radius is 8, I square it. Your theta in this case is pi over 3. And please remember not to use calculator pi. We have to follow instruction. Use 3.142, yeah? Divide by 3. Then you minus sine 60, okay? Calculator in degree mode. There you go, 5.802. Okay, but this is only one area of one segment. Now you look at your diagram. How many segments do you have here? You have 4. Okay, maybe I highlight for you. Once again, when you split this into 2, you see you have 1 segment here, 2 segment here, 3 segment here, and 4. So your total area will be 4 times 5.802. Okay, let's count. Take this answer times 4. Yeah, 5.802 times 4. You should get 23.21. Okay, 23.21. Okay, but sometimes again, there might be a slight difference in answer due to accuracy, right? Because some students may find that it's a bit confusing or annoying to use calculator in different mode. Like this is one, the first one is in radian. Yeah, because we need to leave this in radian based on the fact the formula is derived based on the fact that theta is in radian. Okay. Some students may say, might as well I just change this to radian. All right. And then I just take 3.142, I divide by 3. But if you were to do that, use small decimal point, 1.0473, maybe 1.0473. And then when I use my calculator, I use half r squared. Theta is 1.0473 minus sine 1.0473. But if you were to do that, or to do this calculator must be in radian mode, because I'm finding sine 1.047 radian, not 1.047 degree. Yeah, there's a big difference. You see, picture this. I put degree here. This is in degree. It's a very small value. Yeah, 1 radian is approximately 57.3 degree. So it's a lot bigger, right? So we have to change our calculator mode to radian, right? So you notice the value is different. So here we take half. Your radius is 8 squared. Theta is 1.0473 minus sine 1.0473. Close the bracket. There you go. 5.799. Notice the difference or not? Yeah, 5.799. Okay. Then if you take this is one segment, you're finding total area. Maybe I can put a T for total area. You just have to take this times 4. And in fact, you should just do it one shot. Don't have to do one by one. Yeah? Doing one by one sometimes is a bit more inaccurate. 23.2, right? 23.20. Notice there's slight difference in answer, but they're both okay. Yeah, they're both okay. You can use the first one, you can use the second one. Doesn't matter. Yeah, whether it's 23.1 or 23.21 or 23.20, they're both fine. Okay. By the way, the unit is cm square. Yeah, square cm. Okay, next one, question number 6. This is an interesting question, but it's not difficult. You're given that x, y, z are the 3 consecutive terms of a geometric progression. You're supposed to show that log 10x, not log 10, just log. When you write log here, it can be any base. So normally, if you don't write, if write LG means log base 10. So here they didn't put the base, but it's okay. We can write treat it as LG, right? LG or log base 10 like this. Okay, now I'll just write log, log. Okay, so we know that if this is a geometric progression, right? Your common ratio must be the same. Common ratio is T2, which is R, divide T1, which is X. The ratio must be the same as T3, third term, Z, divide, sorry, I wrote wrongly. This is not what R, this is Y. Y is your second term. Divide first term is X. Divide by third term, Z, divide over second term, Y. Yeah. T2 divide T1. Should I write here? T2 divide T1 equals T3 divide T2. This is a geometric progression. So I'll leave it here. I don't know what to do with this. Leave it first. Okay. Now, then they say the log X, log Y, log Z, they are arithmetic. If it's arithmetic progression, we know your T2 minus T1 must be the same as T3 minus T2. The difference must be the same, the common difference. right? Okay, but we need to show that this is geometric. Yeah, sorry, this is arithmetic. So we don't know yet. So maybe we call this D. We prove that they have the same common difference. D is D2, which is log base y, log, maybe just say log y minus log x. In logarithm, when you minus the number, minus the logarithm, we divide the number inside. Yeah, you know that, right? Log a x minus log a y, you combine is log a x over y. But in this case, we don't write the base. We just follow the question. Question say log, we just write log. Okay, and this is the first common difference. The second common difference will take t3, which is log z, minus t2, which is log y. Now again, in logarithm, we know we can divide them. Minus combine becomes divide, z over y. Okay, now since we know from this equation 1 that z over y is the same as y over z, y over x. See this again, z over y is the same as y over x. So I need to sub in this information inside. This will be y over x. And therefore, this is the same as the common difference for D1, right? So we know that your D2 minus D1 is the same as D3 minus D2. Therefore, we can confirm that log x, log y, and log z, they are the first, the three consecutive term of an arithmetic progression. Well, you don't really have to write this. We can just write shown. So we can show that if your D2 equals D1, that means this must be an arithmetic progression. Okay, let's move on to B. Well, next one. In a quiz, in a math quiz, participants are allowed to answer question consecutively. Each consecutive question answered correctly is worth 1 ringgit, then 2 ringgit, and 4 ringgit. So this is geometry, right? You can see you double the money, right? The game will be stopped if the participants give a wrong answer, and participant only receive 1/10 of the total amount of winning earned. So first part, calculate the amount won by Ryan for the 10 question that was answered correctly. So the first question answered correctly, let me write here, you get 1 ringgit. If you answer the second one correctly, you get 2 ringgit. So that means your common ratio is 2 over 1, which is just 2. Yeah, you double your money at every round. So you want to find out how much money he won on the 10th question, the 10th round. That means you're finding T10. Okay. So I know my A is 1, my R is 2, my N is 10. 10 minus 1 is 9. Remember, for geometric progression, Tn is A, R, N minus 1. So basically, this is 2 power 9. I use your calculator. 2 power 9 is 512. Rm 512. Okay, second one. Ben has won the highest prize in the game, which is 1638.3. Calculate number of questions that he answered correctly. Okay, so now remember he only received 1/10 of the total amount money earned. Yeah, so meaning perhaps he answered first one correct, second one correct, third one correct. The N1 he answered wrongly, and on the N1 he received a total, whatever total amount from the first one until the N1, he get 1/10 of the amount, and that 1/10 of the amount is equals to this, right? So can I say 1/10 of your SN equals to 1638.30. So let's multiply over. Your SN is 16383. No more point. The point is here. If you can drop the 0 at the back. Now, remember for geometric progression, your SN is given by A, Rn minus 1, R minus 1. And my A is still 1. My R is 2, N minus 1. Another 2 minus 1. This is 16383. Okay, to find the value of N, we know this is 2 power N. 2 minus 1 is 1, so no difference. Yeah, if you multiply this. So I just have to bring the 1 over to the right. So 16383 plus 1 becomes 16384. To solve for this, you can actually use trial and error, but sometimes trial and error will take a long time. 2 power what? Maybe 10, maybe 11. Yeah, if you do try one by one, or you can just use logarithm. Introduce log on both sides. Bring the power n down, right? Now we just use your calculator to divide this. So this log 16384, you divide by log 2. And your answer is 14. Yeah. N is then just 14. Okay, next question, question 7. So here we have a trial exam taken by 190 students in the school. The marks for additional mathematics would normally distributed mean of 45, standard deviation 10. So the school principal plans to give a token of appreciation for student who gets 70 marks and above, while student gets 39 on and below have to receive for the exam. So find the probability that students selected randomly will be given a token of appreciation. So meaning the student must achieve a score of more than 70. So number one, we're going to standardize this. I remember the formula for standardization is x minus mu over sigma equals to your z. So here my x is 70, my mean or my mu is 45. The mean score is 45. Standard deviation is 10. So z must be more than 70 minus 45 divided by 10. This is 3.5. Okay, now personally find 2.5. Yeah, this is a bit big number, right? So we can use calculator here. If you're using this calculator, you press mode, go to 3 for stats, right? Press AC. Here we're going to use a probability distribution function. Shift 1 for stats, 5 for distribution, press 3 for R. Remember, if you're using this calculator, you use R. R is your upper tail. Press 2.5. Your answer is this. This means 0.00621. You can use this calculator here, this button here, shift ENG, shift ENG twice. You switch the decimal point to 0. So it's 0.00621. Okay, 0.00621. Now, alternately, you can use your mathematical table. You have to find slowly from here, 2.5. Not to say very difficult to find. It's over here. I hope you can see it. This one. Oh, sorry, this one. 6 to 1. All right. Okay. All right. So going back to this, I know this is my first answer. Yeah, the probability that a student chosen randomly receive a token of appreciation is 0.00621. Okay, next one. Calculate number of students who have to receive the exam. So they say that a student who receive score less than 39 will have to receive, right? So let's find out the probability. So first we standardize it, 39 minus 45 divided by 10. Okay, it's actually negative 6 over 10. 39. If you're not sure, you can use a calculator, right? 39 minus 45 is negative 6 divided by 10, negative 0.6. Okay, negative 0.6 is on the left, right? Over here. We want less than. So remember your mathematical table is based on the upper tail. So we're going to flip it to the right, right? So this is actually the same as the probability of z more than 0.6. Now we can read from the table if you want here. 0.6 is this number, 0.2743, right? 2743. Or you can use a calculator. If you're using this calculator, again, shift 1 for stats, 5 for distribution, 3 for R, 0.6. There you go, 2743. But you could round off to usually 4 decimal point, you'll be able to get the same answer as a mathematical table. Now, but this is probability. Yeah? We are finding the number of students, right, who have to receive out of 190 students who took the exam. Okay, so we can say number of students who receive divide by NS. NS means the total size of your sample space must equals to your probability of student who receive. Number of students who receive is therefore probability 0.2743 multiply NS. Yeah, NS your total 190. Now let's count. Let's take 0.2743 multiply 190. There you go, 52.1. Now we normally have to round off because you're estimating number of students. We don't take negative. We don't take decimal point. So it's approximately 52. We take the nearest integer, right? Yeah, 52 students who has to receive the exam. Okay, next. It is given that 35% of the student obtain marks between M and 45. So between M and 45 marks, they are 35% of the student, 0.35 probability. So here we have to standardize it. Now, when I standardize this M, you need to minus the mean 45, divide standard deviation 10. This 45, if you minus 45, you're going to get 0. So I don't need to standardize it. 45 minus 45 divided 0 divided by minus 45, you get 0, divided by 10, you still get 0. So we know this is on the left. Let me do a sketch. If you standardize it, the center line or the mean will be 0. This is your M minus 45 over 10. Now this area in between is now 0.35. So the area less than that, or maybe I highlight here, the green one should be 0.15. Now, how do I get 0.15 here? How do I get 0.15? We know total is going to be 1. Half of it is 0.5. So the probability of Z less than M minus 45 over 10 is therefore 0.15. Yeah, you can take 0.5 minus 0.35, you get 0.15. Okay, but this part here, you need to use a mathematical table or only this calculator. Only this class width Casio can work backwards. Yeah, if not, use this table. 0.15, you have to slowly find where's 0.15. Okay, the closest I got is pick a number slightly more than 0.15 because we need to subtract. Okay, so slightly more than 0.15 will be this 1.01515. So I need to subtract 15 from the last digit, but I don't have 15. I have 14 or I have 16. Maybe we just take 14. Huh? So how do you read this? We read 1.036. Yeah. When you add the number on top, you have to minus the number below. That means that we read the number on top 1.036. 6, we have to minus 14. Minus 14 from the last two digits of 1515. Okay. So, okay, let me just show you here. We say that your probability of Z more than 1.036 is 0.15. Now, if you find a mathematical table is a bit annoying and don't want to do it, then go and get this calculator. This calculator can do it straight away for you, right? I'm sorry, Silver one can't. Silver one cannot do the trick, right? Only class widths, we press mode, press 7, go to number 3 for inverse norm, right? Key in the area 0.15. Now, the thing about this calculator is that when you do inverse norm means finding Z given probability. Whatever value that you're getting for Z is always negative because we read from the lower tail, right? So you notice you will get a negative 1.036, which is fine. Yeah, which is fine. Huh? Okay, in fact, if you use this calculator, we know it is straight away negative 1.036. But here you notice, when I use the mathematical table, right? My mathematical table is based on upper tail. If this is 0.15, this is 1.036. My Z value is 1.036. So, but you can see from here, what we have here, the green region here is on the left. So we will have to flip it over and say PZ less than negative 1.036 equals to 0.15. Now, why is it important? Because a lot of students will mess up and write this equals to 1.036. It's not true. It is not equals to 1.036. In fact, it is equals to negative 1.036 because your area is on the left. right? When you read from the mathematical table, it's based on the right-hand side. Okay, so let us write m minus 45 over 10 equals negative 1.036. Multiply this over us. Okay, so we are taking 45, all right, minus 1.036 multiplied by 10. So I will get 34.64. 34.64. Okay. Did they mention m must be an integer? No. So in this case, it's okay. We'll just leave our answer m as 34.64. Right? Okay. Question number 8. So this is from the chapter vector. So diagram shows us triangle OAB, C and D are on the straight line OB and AB respectively. Straight line ODAC intersect at point E. So we're supposed to express in terms of X and Y, vector AB, AC, and OD. Okay, I think the first thing is let's just map everything in the diagram. OA is X, so I'm going to write here X, OB is Y, but 3AD is 2AB. That means that AD over AB is 2 over 3. So this is 2. The whole thing is 3. This is 1. At the same time, OC is 3 over 5. That means OC is 3. The whole thing is 5. This is 2. Now, for me, I will label the Y first because you're given OB is Y. So if the whole thing is Y, so this is 3 over 5Y. This will be 2 over 5Y. The whole OB is just 1Y. Okay. Now, next, we're supposed to find AC. So I'm going to do all the working over here. All right. Let's move this to the right a little bit, so a bit more space. Okay. AC. My AC, you can use the diagram here. We go A to O, O to C. Yeah. A to O is negative X. We are going against the direction of X. So it's minus X plus 3 over 5Y. Okay. Let me write here. Minus X plus 3 over 5Y. You can put the 3 over 5Y in front, minus X at the back. It doesn't matter. Yeah. It doesn't matter if you don't rearrange them. Okay. Second one, OD. So how do you go from O to D? Well, I'll show you the standard way, then I'll show you some shortcut. Okay. So if I want to go from O to D, I can go from O to A plus A to D. O to A is X. A to D is 2 over 3 AB. Now, AB is not difficult to find. AB we can see is minus X plus Y. Yeah, minus X plus Y. That is AB. So, okay, I will start off by writing. This is X, 2 over 3 minus X plus Y. When you multiply inside, this is minus 2 over 3X, positive 2 over 3Y. Final answer, 1 over 3X, 2 over 3Y. Okay, that is your vector OD. Okay, next. Now, the second part is you're supposed to find, you're given this information, OE equals HOD, right? OE equals HOD. Okay, that means that if OE equals HOD, meaning this ratio is H, the whole thing is 1. Yeah, I don't have to write that. I just write H here. All right. Now, next, AE is KAC. AE equals to KAC. AE, KAC. That means A to E is K. The whole thing AC is 1. Yeah, again, I don't have to write that. I just write K. So I'm supposed to use these two information to find OE in terms of H and OE in terms of K. Okay, if you use OE in terms of H, let me do it here. OE in terms of H means I must use this one, HOD. Now, I already got OD from the first part. This is 1 over 3X and 2 over 3Y. So this is 1 over 3HX plus 2 over 3HY. Now, I almost forgot. I'm supposed to show you a shortcut for OD. Now, there's a shortcut method to find OD actually. We use what we call the ratio divisor of line segment that we learned in coordinate geometry. in coordinate geometry, if you're finding the point that lies in between, you use nx1, mx2 over m plus n, right? That means, for example, this is your m, this is your n, this is your x1, y1, this is your x2, y2. Remember, we have to multiply across, right? N must multiply x1, m must multiply by x2, divide total m plus n. But for vector, in a way, it's easier because we don't have to deal with x1, x and y. We only have one vector, right? So the shortcut to find OD will be this, right? We take 1, you multiply vector OA, which is x. Then we take 2, you multiply vector OB, which is y. And your total ratio is 1 plus 2 or 2 plus 1, which is 3. You notice this is so fast. This is the same as this answer. Can you see that? It's the same, if the ratio method. That is a shortcut to find, the vector for a line that goes in between. OD must be a line that, pass through a point in between the two other given points. Okay, so now I've got B Roman 1, I've got OE in terms of H. But the next part, I need to find OE in terms of K, X, and Y. So I need to use this information here. AE equals to K AC. Okay, let me continue here. Oops. So if I were to go from O to E and I want to use this AE, I must go O to A to E, right? Let me write here, O to A to E. So this is a slow way. OA is X, AE is KAC. And I've got AC from the first part, right? My AC from A Roman 1 is minus X plus 3 over 5Y. So let's multiply this inside. X minus KX plus 3 over 5 KY. This is K, Just factorize this. 1 minus KX plus 3 over 5 KY. So there you go. I got my vector OE. Now, the next thing is, if you got your two version of OE, we can now solve for H and K. Okay, by the way, here, part C, hence find the values of H and K. So again, I'm going to do it here. Again, another one thing to take note of, if you want to use shortcut to find OE here, you can as well. See here, OE is a point, E is a point that lies in between, right? In between line AC. If this AE is K, this should be 1 minus K. So if you want to use this also can, you see, O to E will be, let's take 1 minus K multiply with the opposite vector. The opposite vector is X. Then I take K multiply with this vector OC. K multiply vector OC. Vector OC is 3 over 5 Y. Now you got to divide by total. What's your total ratio? What is K plus K? K plus 1 minus K is just 1, right? So can you see this is actually the same as the one above? It's a lot faster, right? But I know, for exam purpose, you don't want to do that because you don't want to lose mark, right? So you don't lose mark for working. So yeah, but just so you know, this is a fast way for you to double check or to get the answer. Okay, I want to solve for H and K now. So let's compare the two versions. The first version of OE is this. The coefficient of X is this. Compare with the second version of OE, the coefficient X is 1 minus K. So let's compare X. Okay, we say that 1 over 3H is 1 minus K. H is 3 minus 3K. First equation. Then you compare vector Y. The number in front is 2 over 3H. The number in front is 3 over 5K. So 2 over 3, let me rewrite here. 2 over 3H is 3 over 5K. If you don't like fraction, just multiply everybody by 15 if you want, right? If I times 15, 2 times 15 is 30. So this is 30. 30 divided by 3 is 10. 15 times 3 is 45. 45 divided by 5 is 9. Right? So this is your equation number 2. Let's sub 1 in 2. 10. Right? With 3 minus 3k equals 9k. So 30 minus 30k equals 9k. 30 equals 39k. 30 divide 39, you can divide by 3, is 10 over 13. My k is 10 over 13. As we sub inside equation number 1, my h is 3 minus 3 of 10 over 13. So this is 39 minus 30, which is 9. 9 over 13. Yeah, if you're not sure, you can just use a calculator to double check. All right. Okay, let's move on to question number 9. So this is from the chapter linear law. So the first thing is we're supposed to plot log 10k against log 10h given the table values here. Now we need to first recalculate the table values, right, for log 10 k and log 10h. Okay, so first let's just key in your calculator. Log, this will be 0.6. Maybe I write on top here, negative 0.22. Just take 2 decimal point would do. So this is LGH, negative 0.22. Next, log 0.85. This will give us negative 0.07. Okay, 0.07. Let's do log 1.1. This will give us 0.04. Log 1.4. Yeah, 1.4. This will give us 0.15. Next, we have log 1.83. This will give us 0.26. Then log 2.45. Yeah, 2.45. This will give us 0.39. So I've got my LGH. Then let's do LGK. The first one, log 2.75. Yeah, 2.75. I got 0.44. Next one, log 5.02. 5.02. This will be 0.7. Next, log 8.3. This is 8.36. 0.92. 0.92. Okay. Next, log 13.19. This will be 1.12. Next, log 21.89. This will give us 1.34. Next, log 36.4. And this will give us 1.56. So I'm done really. So I've got all this value. Now I need to plot it on the graph paper. So you can see some of the log h values are negative, but the rest are positive. The smallest being negative 0.22. I think here the question say use the scale of 2 cm to 0.1. So we need to go up to negative 0.3, right? Then this is negative 0.2, negative 0.1. This is my 0. This is 0.1, 0.2, 0.3, and maximum 0.4 because the largest is 0.39. Yeah, you can see that. So this is my LGH. As for your Y value, the largest is 1.5456, smaller 0.44. So I think we can start from 0. And you can see that the scale we have to use is 2 cm to 0.2 unit. So let's start from here. Maybe I draw a line, yeah, over here for the horizontal axis. Let me adjust this there. Okay, over here, move it up a bit. Okay, for the vertical axis, let's start from 0 all the way up. Okay, let me adjust this again. All the way up. Now, how high up? We're not sure. Maybe up to here for now. Okay, so we know we have to use 0.2. So let me zoom in a little bit, right? So hope you can see it. This is 0.2. The line is a bit hard to see also. 0.2, 0.4, 0.6, 1.8, 1.0, 1.2, 1.4, and 1.6. The largest we can start at 1.6 because from the table, the largest I got is 1.56. So yeah, we can start 1.6. Okay, so with that, we know that my graph is done. I just have to plot the scale is done. I have to plot the points. Okay, the first one, negative 0.22 and 0.44. 0.22 and 0.44. So 0.22 is slightly here to the left. 44, I should use two boxes. I can see here, negative 0.22 is here, 0.44 is here, put a cross. Now, the second point that I have to use is negative 0.07 and 0.70. 0.07, 0.70. 0.70 will be in between. 0.770 here, in between. Here we go. Okay, third one, 0.04 and 0.92. 0.04, 0.4, and 0.92. Now, 0.9 will be in between. 0.92 will be higher, so it's over here. Okay. All right. Next, I will have to do 0.15 and 1.12. 0.15, 1.12. Okay, 0.15 is here, 1.12 around here. Okay. Okay, let me just zoom in a bit. So it should be slightly to the right. Here, this point here, put a cross. Yeah. All right. Next, 0.26 and 1.34. 0.26, 1.34. 26 should be slightly more to the left. Okay. And lastly, 0.39 and 1.56. 1.5639 over here. Yep. There you go. Can see it's quite okay. Most of the points are on the line of best fit, but it's all about how you adjust the line. You want to make sure that the line passes through all the point, if not most of the point. Yeah, most of it, if not all the points. Okay, so I think can go up a little bit here. This one can move down a little bit, right? You can see at one point is slightly above. That is the fifth point on the right, slightly above. The fourth point, the second point is slightly below, but that's all right. Yeah, most of the points are very close to the line of best fit. Okay, so to plot, the purpose of plotting this line is to find two things from the graph, to find the gradient and the y-intercept. Okay, my y-intercept, let's zoom in and, okay, wait, I zoom in too much already. Yeah, it's over here. Let's zoom in. This is 0.84. You can see y-intercept is 0.84. My gradient, to calculate gradient, I have to pick 2 points on the graph. And you can take any 2 points, but for me, I like to take horizontal distance of 5. Because any number divided by 5 is a nice number. So I'm going to pick this point over here. It looks like 0.48. 0.48. So this one is negative 0.2, comma 0.48. Can you see that? Okay, not 0.5 yet. Okay, the one on the right, I pick this point here, is 0.3 and 1.4. Okay, now the reason why I pick these 2 points, like I say, I want horizontal distance of 5, so that when you calculate the gradient, my gradient is 1.4 minus 0.48 divide 0.3 minus negative 0.2. So when you divide, you get the nice number. So yeah, let's do 1.4. Okay, let me change the mode first. 1.4 minus 0.48 divide 0.3 minus a plus 0.2. I got 1.84. Yeah, my gradient is 1.84, which is okay, right? Now, you might get a slightly different answer. So 2 things we got from the graph, my gradient, my y-intercept. Now, use the graph to find the values of P and Q. Now, notice that the variable, they are related by this function, K equals square root H power P divided by q. So we need to convert this equation over here to linear form. When you convert to linear form, you have a gradient y-intercept, and you compare the gradient y-intercept with the gradient y-intercept that you got from the graph. Okay, so let me do it over here. Let me copy the question. K equals to square root h over p over q, right? So you're plotting k versus h here. So we're going to introduce log on both sides, left and right, split them, break this up. But this is square root means power half. So there's a half p here. Divide, when you break it up, becomes minus. The half p I transfer in front, minus LGQ. This is LGK. Remember, your LGK is your y, LGH is your x. So this is your big Y, this is your gradient, this is your x, and this is your c. So we know from our graph, the gradient that I calculated earlier is 1.84. This is half p. So half p is 1.84. To find p, we'll take 1.84 multiplied by 2. My answer is 3.68. Okay, 3.68. Now you might get a slightly different answer. That's okay. Then my y-intercept from the graph, from the equation is negative LGQ. From the graph, I got 0.84. So I write 0.84. Let's bring the negative over first, right? Negative 0.84. When you want to find Q from the logarithm, we just press shift log. We call it anti-log, right? Shift log negative 0.84. My answer is 0.1445. Yeah, give your answer correct to 4 significant figure, right? So I got my P and I got my Q, right? Okay, question number 8. This is from the chapter integration. So here we have two curves, y equals fx and y squared equals to 4x plus 1. They both intersect at point A and B. So now we're supposed to state the coordinate point A. So you can see A is basically your y-intercept of this line. So starting from here, y squared equals to 4x plus 1. At y-axis, your x is 0. Your y square is 1, y is just 1. Now, you don't have to put plus minus because you can see A is above the x-axis. Your y value is positive. Therefore, we say A is 1, 0. All right, that is the first part, part A. Part B, given that integration of fx dx from 0 to 2 is m. Now remember, when you integrate a function from, let's say, y equals fx here, right? Let me highlight for you y equals fx here. From 0 to 2 is this, 0 to 2. All right? fx dx, that means we are talking about this region here. This region R here has a value of m. And what we're supposed to do is we're supposed to find area of shaded region, P and Q, in terms of m. Now, in this case, P and Q means P plus Q together, total area. So what we can do is, based on this diagram, you can see we can take this, but you got to be careful. Your P is double. It's not 1, it's double. So maybe I find P first, like this, all right? And then I add this part here, then I minus the region R. Okay? Yeah, take note because P is double of this. Yeah, and you can see it's symmetrical. So let's find P first. Okay. Here I would integrate respect to x-axis. I split this into 2, and then I basically integrate from this value here. This is my x-intercept. We can actually find this. Maybe I do some groundwork first. Let me do some groundwork first. We know at x-axis, your y is 0. So we take 4x plus 1, we let it be 0. X is negative half. So we know this will be from negative half to 0. Okay. Now, let me do the integration here. Your area consists of 2 times your P, right? 2 times of integration negative 1 over 4 to 0. Your function will be, this is y squared. If I bring over is 4x plus 1 to the power of half. Then right here, 4x plus 1 power half dx. Then you add this integration here, which is from 0 to 2, your function again is 4x plus 1 power half dx. Then you minus the region R. Your R is integration of fx dx 0 to 2. Okay, so when we integrate this, yeah, remember when you have composite function, we copy the bracket, increase the power by 1, 3 over 2, divide by the increased power, differentiate inside the bracket. This is from negative 1 over 4 to 0. Okay, second one, same thing, we just copy. It's the same integration, right? Just a different limit. This is 3 over 2 times 4, 0 to 2. This one is just m, okay? Now, let us simplify this. 3 over 4 times 2 is just 6. Maybe I take out 2 over 6 here. Yeah, you can write 1 over 3. Let us sub 0 inside. If I put 0 inside, this is 0 plus 1 power 3 over 2. If I put negative 1 over 4 inside, I actually get negative 1 plus 1, which it is actually 0, right? Then we keep adding this part here. This is 1 over 6. Put 2 inside. 4 times 2 is 8. 8 plus 1. This is 9 power 3 over 2. You minus 0 plus 1 power 3 over 2. And this whole thing, you must minus m. Okay, so let's simplify. This is 1 over 3, right? Yeah. 2 over 6, 1, 3. This 1 power anything is still 1. The second part here is 0. So this is just 1 over 3. Second one is 1 over 6. 8 plus 1 is 9. 9 power 3 over 2 is actually 27. 9 power 3 over 2 is actually 27. Okay, right? But you need to minus 1. Then you minus m. So this is actually 1 over 3. You add with 26 over 3, 26 over 6 is actually 13 over 3. So you add up, you get 14 over 3 minus m. Yeah, there you go. That's your answer for part B. Yeah, your answer will be in terms of number and m. Okay, next, let's talk about a volume. Okay, find the last part. Find the volume generated in terms of pi when the region R is revolved 360 degrees about the x-axis. Okay, given that area of the cross section is this. Okay, so one thing before we do this, I hope you understand that when you have a cylinder, okay, cylinder, if you use a cross section, it's actually a circle. If you rotate, your cylinder has a thickness like this, and this is your radius. Now, you learn that in integration, right? We are actually adding a smaller cylinder. Like, for example, this is a small cylinder here. We rotate like this. We add another cylinder. We add one more cylinder. We keep adding all the cylinder together. So area of one cylinder is pi y square. The thickness is called delta x. If you sum all of them together, we say your y starts from I when I equals to 1 until n. And if your delta x is small, approaching 0, we say your area is integration of pi y square dx, a to b. So you notice that pi y square is actually your area circle, your cross-section area. And the thickness is delta x. In this case, is represented by dx. So this question, in a way, is a bit confusing for some students because they tend to wonder what is this. This cross-section area is actually your pi y square, right? So represent your circular area, and then you just have to add in a dx. So we already have your pi y square here. This whole thing is already pi y square. You don't have to add in a pi. You don't have to square it. It's already given here. Just add in a dx. So to calculate the volume, yeah, you can see shaded region R is here. Over here, the lower limit is 0, upper limit is 2. So we integrate 0 to 2. Your pi y squared is already given here. So you already expanded, right? Just add in a dx. Now, maybe you can take out the 1 over 4 pi. As I integrate this, I get x power 5 over 5. Second one, as I integrate 4x3 over 3, this is 4x. Lower limit 0, upper limit 2. So let's put 2 inside. 2 power 5, 32, right? 2 power 3, I sub 2 inside 2 power 3 is 8. Then this is 4 times 2. You minus 0. Okay, now let's use our calculator. This is 1 over 4. Keep the pi, don't need to type the pi in your calculator. 32 over 5. Then you plus with 4 times 8 is 32, but it's over 3. Then you add with 4 times 2 is 8. This answer is 94 over 15. So maybe we write in mixed number, 6, 4 over 15 pi 6, 4 over 15 pi unit cube. There you go. That's your answer. Okay, question number 11. So here we're supposed to prove that 4 over 2 cotangent theta minus 2 tangent theta equals tangent 2 theta. So this one is trigonometry. So I think we start from the left-hand side. But from the left-hand side, you can see actually you can divide everything by 2, top and bottom by 2. So if I just divide top and bottom by 2, I'll get 2. And this will be cotangent theta minus tangent theta. Now, we know cotangent is 1 over tangent. So I'm going to write 1 over tangent here. Then this is tangent here. And we also know that tangent 2 theta formula is given by 2 tangent theta 1 minus tangent square theta. If you can't remember, please refer to the list of formula. So to get this right, I need to multiply both sides, top and bottom, with tangent theta. By doing so, I get 2 tangent theta. And when you times the tangent with 1 over tangent, you cancel out, you're left with 1. And the tangent multiplied with tangent, it gives us tangent squared. And this itself is the same as tangent 2 theta, which is your right-hand side. Okay? All right. Now, next, we're supposed to solve this equation. Okay, this is Roman 1, Roman 2. To solve this equation, you can see that the entire thing here, see, is the same as this. So we have to use the result. And we can just substitute the whole thing with tangent 2 theta. And my tangent 2 theta is now sec 3 over 2. Okay, so what we can do is we can use your calculator, find the reference angle. Remember to use calculator in this case, degree, can you see, it's in degree 0 to 270. So shift mode, change your calculator to, okay, one more time, shift mode, change your calculator to degree mode. So shift tangent sec 3 divide by 2. This will be 40.9. Yeah, my reference angle is 40.9. But take note that theta is between 0 to 270. 2 theta will be between 0 to 540. So we know we have to do one cycle, 0, 180, 360, one cycle, and then follow on by 360 to 540. Yeah, so basically 1.5 cycle. Now, this tangent is positive. Tangent is positive in quadrant number 1 and number 3, and second cycle, quadrant 1. So we say 2 theta is either 40.89, first answer. Second answer, 180 plus 40.89. Next answer, 360 plus 40.89. Only 3 answers. Now we don't do anything more than that because the maximum is until 540. So whatever we have here, we have to divide by 2. Like the first one, 40, let's take 40.89 divided by 2. All right, this answer is 20.45. 20.45. Second answer, you need to add in the 180. Yeah? So I'm going to move this up, add in the 180. Okay, 180 plus this divided by 2. I got 110.45. 110.45. Next one, we take 360 plus, right? 360, just move it here. 360 plus, and this will give us 200.45. 200.45. Okay. All right, so part A, we're done. Part B, we're now going to sketch a graph. Okay, so for graph sketching, I'm going to this over here a little bit. Okay, I'm going to start off by rearranging this equation. You can see we're supposed to sketch this graph, but let's make y as a subject. 4y is now bring everything to the right, you get negative modulus 8 sine 2x plus 8. Let's divide by 4. When you divide by 4, this is negative 2 modulus 2 sine 2x plus 2. Okay, I know it's a bit hard to try to figure out how to draw this at one go. Let's do one by one. And let me show you step by step. We know the basic sine x graph looks like this. We start from 0, go up, down, and up, right? Now, this is from 0 to 2 pi. Now, the next thing is, what if you have a 2 in front? Yeah, let me draw step by step. If you have a, originally it's 1, right? So if you have 2 in front, now we have to draw up and down like this with the amplitude of 2, right? Still quite easy. Okay, 0 to pi. Then let's draw 2 sine 2x. 2 sine 2x means I have to draw 2 cycles from 0 to 2 pi. 1 cycle, 2 cycle, 0 to pi. All right. But notice that in this question, we're supposed to draw until 3 over 2 pi. So maybe I trim it off here. I don't have to draw more than that. That means I only draw from 1 cycle to, 3, like a 3 shape. Yeah. 1, 2, 3, 3. Yeah. It consists of 1.5 cycle. Okay. Now, maximum is still 2, minimum minus 2. The next one is I'm going to put a modulus. I'm doing very, very slowly here. When you modulus, what happens is we are only taking the positive side. Whatever falls below here, we flip it up. It becomes positive. Yeah, it's inverted. So this is 0 to 2. Yeah, we don't need this side. Okay. Then let's do negative of a modulus. I know this is really long. Huh? Negative modulus 2 sine 2x. So that means we have to flip this upside down. So it goes down to 3, right? Okay, like a 3 mountain, if you like, 3 pi over 2. This is minus 2. This is 0. And lastly, because you have a plus 2, I have to shift this up by 2. If you shift it up by 2, the maximum will be at 2. Okay, maybe I should use a straight line from here. It's better. Yeah, you can see 1. Let's draw a horizontal line here, 2. Okay, now you can see that the whole graph is above the x-axis. Nothing is below. Everything is above the x-axis. This is 2. Maybe we draw 6 segment here, like this. All right, this is your x. This is 3 pi over 2. You don't have to label every single segment. This is 1 pi over 2. This is pi. So we have to go, this one you shift up by 2, so it go down. Now, if you find this a bit too big, you can just draw a bit lower. It goes down and up. Okay, in order to get the nicer looking graph, right, you can, for you guys, you use a 2B pencil or thicker, basically thicker pencil can hide your ugly drawing, right, fully. So it goes down and up. Okay, this part I need to adjust it. One more time. Up. It goes down and up and down and up. Okay, this part I can improvise. Down. This part can adjust it. Okay, so yeah, a bit hard to draw, right? Okay, so my graph is done. Now, the next part is this. I have to find the range of values of k for this equation such that the equation has 6 solutions. Okay, so this equation, if you look at it, right, it's actually we can rearrange this equation by first bringing the 4k to the right. So 8 minus 8 modulus 8 sine 2x equals to 4k. So as we divide by 4, so we have 2 minus modulus 2 sine 2x equals to k. So basically, this is the same as our first graph, right? And the second graph that we have to draw on the same axis is y equals k. Now we know y equals k is a horizontal line. So to draw a horizontal line such that we have exactly 6 solutions. And remember, number of solution is the number of intersections. So we can draw it here. If I draw a horizontal line here, how many solutions do you have? 0. If I draw it here, you have exactly 3. If I draw it here, I'll have 6. If I draw it here, I'll have 4. If I draw it here, I have none, right? So in order to have exactly 6 solutions, the line that I have to draw should be in between 0 and 2, right? So we say that in order to have 6 solutions, your k should be anything between 0 and 2. Okay, non-inclusive, it doesn't include 2, right? It doesn't include 0. Yeah, anything between 0 to 2, right? Okay, question number 12. So here we have cyclic quadrilateral. Yeah, so ABCD that lies inside a circle here. So you're supposed to find the length of AC. Now we know AC is the opposite to this angle 64. We are given 12.5, AB is 12.5, BC is 8.4. So we can use the cosine rule formula. AC square is 12.5 square plus 8.4 square minus 2, 12.5, 8.4 cos angle in between 64. Okay, so calculator 12.5, 8.4 minus 2 times 12.5 times 8.4 times cos angle 64. So cosine ruler, square root it, straight away, do it one shot, AC 11.61. Okay, give your answer correct to 4 significant figure will do. I don't have to give more. All right, second one. I want to find angle CAD. But we cannot find angle CAD directly because although you know this length, 11.61, and here we can see this, like I say, it's a cyclic quadrilateral. Cyclic quadrilateral has one important feature, that is the opposite angle here is 180 minus. We call it the interior opposite angle. So this angle over here, can we just write it straight away? Angle ADC is 180 minus 64, which is 116. Yeah, this angle over here is 116. Now you notice that we cannot find CAD directly because the opposite side to CAD is CD. I don't know the length of CD, but I do know the length of AC and AD. So what we can do is we can find angle C, this angle C here, or ACD first by using sine rule. And remember, sine rule works like this. We must have a pair of angle and the opposite side. So I want to find angle ACD first. The opposite side is 6. Then we take sine of this angle ADC at 116. Opposite side is 11.6. Okay, use your calculator. Sine 116 divide by 11.61. You multiply by 6. Whatever I get, shift sine, answer equals 27.68. Yeah, angle ACD is 27.68. Okay, once you know this angle, 27.68, I can now find angle CAD. Yeah, since this is a triangle, right? A total interior angle for triangle is 180. You minus 27.68. You minus 116. Okay, let's count. 180 minus 27.68 minus 116. You should get 36.32. Yeah, this angle is 36.32. Okay, done. Next, we are supposed to find area of triangle ACD. Okay, to find area of triangle, very simple. Area of triangle ACD is this, basically is area. Now, we need to use half AB sine C. Well, we know the length of these two sides. We know 6, we know 11.61, and we know this angle is 36.32, right? 36.32. So we can use area as half 11.61. This is 6. We take the sine of 36.32. Now use your calculator, everyone. Half 11.61 and 6 followed by sine 36.32. Okay, and my answer is 20.63. Yeah, 20.63. Okay. Now, the last part, we are finding the, move it down, B Roman 2, the shortest distance from a point D to line AC. Shortest distance from a point to a line is what we call a perpendicular distance. Maybe I draw here a perpendicular distance. Now, this may not be isosceles, but the most important thing is that this is your height of your triangle. Your base is 11.61. Your height is, let's say, h. So we say that half times base times height is 20.63. And I want to find my height, right? Now let's take 20.63, multiply by 2, divide 11.61. What I have here for h is 3.554. 3.554. Okay? It's not difficult, right? Yeah. In fact, I would say this is one of the easier questions from this paper. Okay, question 13. This is from the chapter index number. So here we have a table that shows price indices and weightages of 4 material used in production of a pair of sandals. So yeah, the first part, you're supposed to calculate, okay, let me zoom out a bit. You're supposed to calculate the price of material B in the year 2021. If the price in the year 2019 was 15 ringgit 50 cent. Material P has an index of 120. So we know we can use the formula for index number, which is price of 2019 to 2021. 19 is a base year, 21 is a current year. Price in 2021 divided by 19 times 100. Very, very simple formula. The index is 120. The price in 2021, we don't know. Price in 2019 is 15 ringgit 50 cent. So your P21 would be, let's take 120 times 15.5 divide by 100. So my price in this case, 18 ringgit and 60 cent. Yeah, 18 ringgit and 60 cent. Okay, then we go on with price of material S in 2019 if the price in 2021 is 18 ringgit. Yeah, so the index now is 125. So we say 125 equals price in the year 2021 is 18 ringgit. Price in the year 19, I don't know, times 100. So let's take 125 divide, we bring it down. So basically we're taking 18 divide 125 times 100. So I got 14 ringgit and 40 cent. Yeah, 14 ringgit and 40 cent. That's the price in the year 2019. Okay, moving on. The next one, you're supposed to find the value of x given that the composite index for the cost of making a pair of sandals in the year 2021 based on 2019 is 135. Okay, so I'm going to do it here because it's easier for me to refer to the table here. We know this composite index, the whole thing is going to be 135. Yeah, it is given as 135. You're supposed to find the value of x. And we know to calculate composite index, basically we take the individual price, 120 for P, multiply with the weightage, then Q is x, you must multiply by 3, so it's 3x. R is 130, you multiply by 4. S is 125, you multiply by 1. Your total weightage is 2 plus 3 plus 4 plus 1. And the index is 135. Okay, 135. So let's work this out. This is 120 times 2 plus 130 times 4. And then you add with 125. So this figure is 885. So 3x plus 885. This is 10. 2 plus 3 plus 4 plus 1 is 10. Then I multiply over, it's going to give us 1350, right? So 1350, you minus 885, 465. You divide by 3, 465 divided by 3, x is 155. Okay, simple. Now next, hence calculate the composite index for the cost of making a pair of sandals in year 2022 based on the year 2019. Okay, so this part C, yeah? All right. So you notice that we are given the changes in price from year 2021 to 22. So when you increase by 15% is the index is 115, unchanged the index is 100, decrease by 5% is 95, increase by 8% is 108. Now, always remember, for me, when I want to calculate the overall increment, there are 3 years involved. One is 2019, second 2021, next is 2022. So for example, for item P, right, material P, 19 to 21, we know is 120. 21 to 22, we know increase by 115, 15%. Huh? So to find the overall increment, we basically take 120. Let me write over here. Okay, so this is material P. We take 120 times 115 over 100. Okay, use a calculator. 120 times 115 over 100. This will give us 138. So we're going to do the same for every single one. Yeah. For Q, it's the same thing. We take X, which is, we already know X, right? My X is 155, right? Unchanged means we multiply by 100. Here you divide by 100 is still 155. For R is 130. You decrease by 5% is 95 over 100. So it's 130 times 95 over 100. That will give us 123.5. Okay. Next, for S is 125. You multiply by 108. You divide by 100. Okay. 125 times 108 divide 100. This will give us 135. So I've got all the indices for year 2019 to 2022. So to calculate the composite index, the same thing, right? We take the index 138, multiply by 2. Your weightage remains the same, 2. 155 times 3, 123.5 times 4, and 135 times 1. Total weightage is 10. I'm just going to write 10 straight away. So 138 times 2 plus 155 times 3. Next, 123.5 times 4 and 135. Divide by 10, I got 137. Right? My index is 137. Okay, next, the last part. They say that the cost of making a pair of sandals in year 2022, if the corresponding cost in 2019 is 45 ringgit 30 cents. So we already know the cost. This is from 2019 to 2022. The overall cost has increased by 37%. So we want to find the cost in 2022, given the cost in 2019 is 45 ringgit and 30 cents. So basically, we're using back the same formula as this other normal index number. Price in 2022 divided by price in 2019 times 100 is going to give us this index 137. So we know this is 45 ringgit and 60 cents. Let me check. Yeah, 30 cents. 45 ringgit 30 cents. You just multiply over. Use your calculator. 137 times 45, 30 divided 100. Answer is 6206. Yeah, 6206. Okay. Okay, question number 14. So here we have a bakery that makes 2 types of cake, X and X cakes of P, Y cakes of Q per week using flour A and B. So both cakes require different quantities of flour A and B. So each cake of P requires 40 grams of flour A and 30 grams of flour B. Okay, maybe I list out like this. You have cake P and Q. It needs flour A and flour B. They say each cake of P requires 40 grams of flour A and 30 grams of flour B. While cake Q requires 20 grams of flour A, 60 grams of flour B. So the first thing is we need to write 3 inequality. They say the production of the cakes are based on the following constraint. So the first one is ratio number of kick P produced to number of kick Q is more than 1:4. So what we can do is we can write like this. Kick P is X, kick Q is Y. Rather than writing in ratio form, write in proportion. Remember, proportion are two equivalent fraction. And this must be more than 1/4. So when we cross multiply, we say 4x is more than y, y is less than 4x. Yeah. So the first one is y less than 4x. Okay. Now the second one, flour A can only be used at most 1,800 grams per week. Now if you look at flour A, right, you make x cake B and y cake Q. So we can say your each cake B needs 40 grams. So I make x cake B. So I need 40 times x. And for cake Q, each one I need 20 grams. In this case, I'm making y cake Q. So I add 20y. And this sum must be at most. At most means less equals 1,800. Maybe I write a bit lower here, no space. 40x 20y less equals 1,800. At most is maximum. So here we notice that we can divide by 20. As I divide by 20, 2x plus y less equals to 90. Now, even if you don't divide, it's okay. I divide it so that it's easier for me to draw the graph later on. Next, for flour B, I need this one, flour B, I need at least 1,800 per week. Yeah. So look at how many gram flour B do I need for cake B? I need 30 since I'm making x number of cake B, so 30 times x. For cake Q, I put 60 times y. This will be at least 1,500. So again, we can divide by 30. So x plus 2y greater equals to 50. So I have three inequality here. The first one is this, y less than 4x. Second one, 2x plus y less equals to 90. Third one, x plus 2y greater equals to 50. All right. So with that, I'm going to draw these three lines on the graph so that I can construct and shade the region that satisfy the following constraint. Okay, so I don't know whether you know this. For y equals to 4x, right, we can just use a simple table of values. That is, we let x be 0, your y also 0, right? The scale is given here is 2 cm to 10, right? So maybe I just put 0, 10, 20. This will be 30, 40, 50, 60. Maybe 70 is enough. I'm not sure. Yeah, not enough, we extend. This is 10, 20, 30, 40, 50, 60, 70, 80. Maybe 80 is enough. Okay. Again, not enough, we just extend. So let me draw the line here, easier to see. Draw the horizontal axis over here. Move it up. Okay, and I draw a vertical axis. Vertical axis over here. Yeah. Okay, done. So we know that the first point I have for y equals 4x is 0, 0. I need a second point. The first point is here, 0, 0. Second point, maybe you can put anything like 10 and 40. That's simple, right? Or you can put 20, 80, right? Maybe 20, 80, so I can draw a bit higher. But in this case, it's not a straight line. It's not a solid line. It's a dotted line. But let me just draw this line, then I can just trace it over. Yeah, 20, 80 is over here. Yeah, because this is a it's non-inclusive. There's no equal sign. It's y greater less than 4x. So let's just draw dotted line on it, right? Let me draw a dotted line on this. Later we can rub it off. Okay. Sorry, my line is not very nice. All right, I just remove it. Okay, it's really not very nice. Is okay, y equals 2x. Okay, 4x. The next one, I'm going to draw this line, 40x 20y is actually 2x plus y. Sorry, I think this one I have accidentally shifted it down or up. Yeah, so it's a bit, should to move it down a little bit. Hope you can see it. Yeah, okay, I think I'll just use this. 2x plus y equals 90. So this is 2x plus y equals 90. Now let's take x equals to 0. Your y is 90. And y equals to 0. If your y is 0, x is 45. Okay, I think in this case, we have to move this up a little bit because we need up to 40. We need up to 90. Yeah? So I will have to move this line higher up to 90. Okay, let's move it higher up to 90 here. So 90 is here. This is my y. Okay, all right. So let's draw. Okay, I think this one has to go down. A bit downward. Ah, this is better. Yeah, because it's off position already. Okay, it's supposed to be like this. Okay, come. Let's draw 0, 90, which is here, and 45, 0, which is here. This is 45. Okay, so we need 2 points. Okay, need to zoom out a bit, no space. We need these 2 points and join the straight line. So this one will be around here. Okay, so this is a solid line. Bit closer here. Okay, so I've got this line is y equals to, well, let me write here, 2x plus y equals 90. Okay, the third line I have to draw is x plus 2y equals to 50. Again, we use table values, x and y. When x is 0, 50 divided to 25. When y is 0, x is 50. So 0, 25, which is over here, 50, 0, which is over here. So let's draw. Okay, straight line, go downwards like this. So move it up. Okay, so that's my straight line. Okay, so this line is x plus 2y equals 50. Okay, so the region that we want is this. Number one, it must be, y must be less than 4x. So we know it must be below here. Maybe I just use this shading here, below here. Number two, it must be 2x plus y must be less than 90. So that means it must be below this line here, right? Number three, it must, x plus 2y must greater equals 50. So it's here, right? Above this straight line. Okay. Wait, I hope yeah, my labeling sometimes a bit hard to see. So maybe you can move this if you're confused. This one, you can move it to the other side. The 90 here, you can move it to up here. I hope you know the 2x plus y equals 90 is representing the other line. Yeah, maybe I'll just leave it. Yeah, it's representing this line here. Okay, all right. Anyway, I got my region R done. Now, next, use the graph to answer the following question. Okay, let's look at part C. Find the maximum number of cake Q. Okay, cake Q is your y. Yeah? The maximum y I can get is here. Sometimes a bit hard to see. Let me just zoom in here. We cannot take 60. Even look at this, you thought we can take 60, right? We can't take 60 because it cannot include the point here. So we have to move down, right? We cannot take a point on this line because it does not include y equals 4x. So sorry, we have to move it down. Take the nearest integer. The maximum we can get is 59, not 60, yeah? 59. Okay? All right. So that is to answer the first part of C. Okay. All right. So y maximum is 59. Okay. Next one. The cost of making cake P and Q is 40 ringgit and 25 respectively. Owner of the bakery want to sell each cake with profit of 35%. Calculate the minimum amount profit that to be earned. Okay, so first of all, we need to know the costs, right? 40x and 55y. So let me write over here. We have to use an objective function. This is C Roman 2. 40x 55y, we let it be k. So we need to draw this line on the same axis. But for me, I'd like to change it to y equals mx plus c, bring it over, negative 40x plus k. I divide everything by 5. As I divide by 5, you get 8 over 11x, k over 50, divide by 5, divide by 55. Okay, so remember your k is determined by your y-intercept. If your y-intercept is bigger, then it's maximum. If your y-intercept is minimum, then your k will be minimum. So, but the main thing is I have to draw a straight line with a negative gradient 8 over 11. So how do you draw 8 over 11? Okay, this is interesting. Maybe I just use this 40 over 55. That is, I draw a line with the gradient 40 over 55. Okay, let me just move it up a little bit. Where is 40 over 55? Okay, that means your y is 40, your x is 55. Okay, 40 over 55 is here. So something like that. Okay, so let's take this and move it down. Okay, normally we use dotted line, but for this case, I think no choice. I just use this solid line here. I'm gonna copy this. Oops. I'm gonna copy this. Yeah. And paste it somewhere here. Can I paste it? Okay, let me try to paste it here. Okay, so I paste a line. And the line should pass through a point, at least a point in the region that gives us the minimum y-intercept. So the point in the region, right? Remember, you cannot take the dotted line here. Sorry, you cannot take the dotted line. Wait. Yeah, cannot take the dotted line. We have to take a point inside the region. So in this case, oh, so sorry. This thing keep running out. Yeah, it looks like I cannot zoom in too much. Okay, we cannot take this dotted line. Let me take a line above, slightly above. So the point that I have to take, in this case, it looks like 20, let me see, 6, can I take 6? 6 and 22, right? Okay, I can't zoom into inside here. Oh, yeah, I don't know. I just cannot zoom in, right? It just ran out. So it's about 6 and 22. So we have to pick a point inside. We cannot take the point on the line. So it's 6, around 622. So this will give us a minimum cost. We want a minimum cost, right? So now let's go back to this question. Minimum cost happen. We know that from here, your K is minimum. K is your cost at 622. So K minimum will be 40 times 6, 55 times 22. Okay, so let's use a calculator. 40 times 6 plus 55 times 22. So this will give us 1450. Yeah, RM 1450. Okay, so this is a minimum cost. The question say the profit must be 35%. Okay, actually there is 2 different ways of counting a profit. One is called a markup. One is called if you talk about profit is based on the selling price, right? So if you say your profit of 35% is your selling price, 35% is profit, then 65% is cost, right? So, but in this context, for this question, I think if you look at the marking scheme, what they are trying to say is a markup. The person who sells, the owner of the bakery wants to mark up 35%. Okay, so that means your cost is already 1450. To mark up 35% profit, so we need to take the profit as 35% of this amount, 1450, right? This is called marking up. So times 35 over 100, this will be 507.50. Yeah, 507.50. There you go. That is the profit, right? Okay. Last question is from kinematics of linear motion. So here we have a particle that move along straight line such that the velocity is given by this v equals to, let me write here, v equals to p plus qt. And they say that the particle is 48 meters to the left when t is 6. Okay, remember 48 meters to the left is a displacement. So to find displacement from velocity, we will have to integrate. So when you integrate this, you should get pt plus qt squared over 2 plus c. Now, because the question says it passes through point O, t is time in second after passing through O. So we know when you start the clock, t is 0, s is 0, c should be 0. So my displacement function is therefore this. Okay, so what I need to do is to sub in initial displacement. I mean, the displacement is 48 when t is 6. So we put negative 48 because it's on the left when t is 6. So I put 6 inside. This is 6 times p. This is 6 square divided by 2. 6 square divided by 2 is 36. 36 divided by 2 is 18. So we say 6p plus 18q. Okay, I hope I didn't make any mistake here. This one is t squared, sorry. So when you cube it, this is 3 over 3. Sorry, for the mistake, this is 3 over 3. So this is 6 power 3 over 3. So 72. 6 power 3 is 216. 6 power 3 is 216. You divide by 3 is 72. So this is 72q equals to negative 48. So I think we can divide by 6. Make the number smaller. 72 divided 6 is 12. 48 divided 6 is negative 8. This is your first equation. Okay, then they say that acceleration is negative 4 when t is 2. So let's differentiate. Differentiate p, you get 0. Differentiate velocity is acceleration. Differentiate qt. There's a square here. Sorry, there's a t square here. Differentiate qt square, you get 2qt. We know the acceleration is negative 4 when t is 2, right? So my t is negative, my q is negative 1. Okay, sub in, divide them, q is negative 1. As you sub inside equation 1, p plus 12 times minus 1 is minus 8. Minus 12 bring over is 12. 12 minus 8, p is just 4. Okay, so I got the values of p and q. Now next, find the time when the particle stopped instantaneously. Well, particles stop instantaneously when v is 0. So we know our v already. My v is p, which is 4. Q is negative 1. T squared, you let it be 0. I think you can bring the t squared over, square root it, t is 2. Now you don't have to put plus minus because time t is always more than 0. Then let's find the distance traveled by the particle during the 5th second. Okay, first we need to find our displacement function. I know that p is 4. I put 4 inside here. I'm putting inside here. 4t, q is negative 1. So it's negative 1 over 3t cubed. So distance traveled in the 5th second is actually s5 minus s4. Let's put 5 inside. 4 times 5 minus 1 over 3. 5 cubed is 125. S4 will be 4 times 4 minus 134 cubed is 64. Okay, use your calculator. This is 20 minus 125 over 3. Then you minus, open bracket, 4 times 4 is 16, minus 64 over 3. Okay, my answer is negative 16 over 3. Okay, although you get negative, right, it doesn't matter because distance is always positive, right? This one simply means the particle is moving to the left. So we just ignore the negative, drop the negatives, and say that the distance traveled in the 5th second is 16, 1 over 3. All right, so we're done for the discussion of this paper. Yeah, thank you very much for watching. Yeah, I hope to see you in the next video.